In this video, we're going to look at example 1 from our notes on section 1.7 on limits and continuity. So in example 1, we're asked, is f of x defined piecewise? So on one chunk of our graph, it's defined as this output if x is not equal to 1 and is equal to 6 if x is equal to -1. Is this function continuous at x equals 1? Justify your answer. So just to get an idea of what this graph looks like. So if we have our x-axis here, -1 is the x value that we're interested in. And what we're told is that our graph is defined some way outside of x equals -1. So it looks something. And then it's defined somewhere else at x equals -1. So one thing to note, maybe why the graph is defined like this or why the function is defined like this, is because can we plug into this function here, x equals -1? If we do that, then we get a 0 on the denominator. So as is written, this function here, just this one, does not have x equals -1 in its domain. But if we define f of -1 as 6, then that means we have defined f of -1. Okay, so that's just to get a little sense of the type of graph that we are dealing with here. So in order to check if our function is continuous at x equals -1, we need to check if these three conditions that we saw in the definition box are satisfied. So let's write that down. Check if the three conditions for continuous at x equals -1 are met. All right. So first condition, f of -1 must exist. Does it? Well, we are told that when x equals -1, the output is 6. So we're told f of -1 equals 6. So check, satisfied. Now let's look at number 2, or the second condition. We need to check, does the limit as x goes to -1 of f of x exist? Well, let's check. So we need to compute the limit as x goes to -1 of x squared minus 1 over x plus 1. So as we've seen, we can't just plug in x equals -1 here because we get a 0 in the denominator. But notice we can expand that numerator and maybe cancel out a 0 in the denominator. So let's write that out. So we see the limit as x goes to -1, or rather this first fraction is equal to x minus 1 times x plus 1, if we factor out that numerator, divided by x plus 1. So we can check, does anything cancel? It certainly does. The x plus 1 in the numerator cancels with the x plus 1 in the denominator. So we're left with, this is equal to the limit as x goes to -1 of x minus 1. So now there's nothing wrong with plugging in x equals -1 here, because this expression here is defined for x equals -1. So then this just becomes -1 minus 1, which is equal to -2. So that gets a check mark. The limit does exist. So now let's check the third condition. That means we need to check if the limit as x goes to -1 of f of x equals f of -1. Well, from part 2, we saw that this limit is equal to -2. But we saw from part 1 that f of -1 is equal to 6. So these two values are not equal. So this condition is not satisfied. So what does that mean? That means the function f of x is not continuous at x equals -1. And that's because this third condition is not satisfied. Awesome. Great work, everyone. Please feel free to rewatch this video to help this concept of continuity become more familiar. Thank you for listening.